We started a new module 6, and as I said to the Hayden, like it is really like relatively short modules. There'll be only be like 3 to 4 chapters too, but we actually need to do a little bit of like a depth study for this too. So highly likely, if you've done a test last year, which means you may have a kind of depth study related to like genetic technologies. So what we're going to do after we actually complete the contents, we are actually going to do a little bit of depth study. So I will probably ask you to write an essay or something like very similar to like a school exam or the HSC styles too. So basically kind of research some of the things and then we're going to fill it up. But for now, let's start module 6, chapter 1. Excuse me. Okay, let's start from just quickly revising what we did in module 5. Don't lose that module 5 contents, guys, too. Module 5 is all about the heredity. Okay, just gotta spend like 5 to 10 minutes for that. Eric, what do we learn in heredity module 5?
Asexual and sexual reproduction.
So we learned about reproduction, and that's divided into the sexual and asexual. Good. Do you remember the difference between the sexual and asexual reproduction?
Like one is like the line of parents.
Mm-hmm.
Yep.
So asexual is using like, in terms of the cell division, so I can just divide it here. The cell division is another type. Division is another one too. In terms of cell division, sexual reproduction usually go through the meiosis, which is the decrease in number of the chromosomes from the haploid, from the diploid. Asexual is going through the most likely the mitosis. So that's why they're producing identical genetic information passed on too. Inside the sexual, we learnt about internal and external fertilization. Now, I believe like you probably have a good understanding and ideas about the the difference between similarity and difference between internal and external fertilizations too. So I won't go too much detail about it. Cell division, as I said, we had 2: mitosis and meiosis. So I hope you actually remember those steps of the mitosis meiosis, which can be summarized as PMAT. Meiosis has 2-step PMAT 1, PMAT 2, the meiosis 1, meiosis 2. Inside the meiosis, if you remember that, there are 2 times the PMAT, and yep. Okay. Inside the meiosis, there's a very important thing called the crossing over. Diana, what is crossing over and why is it so important?
It's like exchanging genetic material.
Yep. During which phase? Prophase, metaphase, etaphase, telophase? Thinking about what I mean, like PMAT stands for too. I've described P is a preparation, M is like the going. You may imagine about visualization of that too. They are lining up, okay, and they're like lining in the center, and they get detached, and they're gonna complete. Any idea? Actually, any idea? When the crossing overs happen? During the meiosis. Prophase, meiosis 1, meiosis 2. Meiosis 1. It's good to remember this as well too. During the meiosis 1, it goes through the prophase. Prophase, okay, the way you can think of PMAT, P, is a preparation. Means that they're lining up, they're preparing. And during the preparation process, they are crossing over, means exchanging genetic materials in the first meiosis. Okay, that was the one. Aaron, is there anything else we learned in the heredity, the module 5?
Fertilization as well. We also learned about like just like fungi. Oh no, we already did that.
We did that here. I did it here. Fungi and other things.
We learned about like sex-linked.
Oh, okay. So pedigrees, or like Mendes law, or it's called inheritance. Can you tell me a little more about those? Okay, sex-linked. Okay, inheritance. A little bit more about this, please. According, like, all using the Mendes law. There are two laws of Mendel's. Not too sure.
Something about X or like.
It is something about maybe more than that. Maybe like a whole general too. Eric, anything else? Mendes law.
I remember like the independent. So
One is the independent assortment. Okay. Eric, I think it's a good idea to write this one down as well too as we go. Just summarizing all that. What is independent assortment?
it's like one trait,
Hmm.
like an allele to a specific trait doesn't affect like another trait.
Very good. So independent means that your hair color from the mom and dad is not really affecting your height. They're independent. Means that they're independently inherited. So when we use the example of the pea plant, the colors of flower would not be affected by like the tallness or like the weight of that either too. Anything else for the Mendes law, independent assortment? Actually, segregation. So segregation. What does it mean by law of the segregation?
Like during meiosis,
It means that one trait coming from like a trait coming from the parent, and they're going to segregate it to, so it kind of inherited to the next generation or next offsprings. And within inside the inheritance, we learned about different type of the pedigrees. Do you remember any examples of the pedigrees or examples of the some inheritance? Give example. The one is sex-linked. Autosomal. Thinking about, we talked about dominant and recessive. Okay, we talked about codominance. We talked about incomplete dominance. Okay, so autosomal means like it's not really related to like any of the sex, like a gamete. So sex link is only inherited by sex. And when it's a sex as well too, we have an X dominant, like a Y dominant as well too. All of those are asked you to practice during your holiday homework. So you probably had a really like some similar style of questions. In Module 5, we also learned about what's going into, like not only just the level of the cells, we get deep into the cells and then looking into what happens to the nucleus during the mitosis meiosis or the cell division process. So we learned about first the DNA replication, which is also related to cell division part over here too. And I ask you to memorize the steps of DNA replication, including all the enzyme involving into DNA replications. That's including the DNA polymerase. We also did something about protein synthesis. Now, within the protein synthesis, you have to understand like the procedure of the protein synthesis. One is started from what happens in the nucleus called a translation. Two is a transaction. No, translation and transcription. Thank you. Other way around. Transcription and translation. So one is happening inside the nucleus, that mRNA is copying down the DNA strand. So again, you have to understand, like memorize the procedure of that too. Translation is what happens in the ribosome, is the actual process of producing the amino acid, or like a chains of the amino acid. Therefore, we get something known as polypeptide. those polypeptides get like entangled or they kind of combine too and producing the proteins from that too. So polypeptide is simply a long chain amino acid. Once they are kind of squashed, kind of joined, a little bit of the chemistry due to some bondings or the hydrogen bondings, they actually forms the proteins, we know that too. These are the summary of the module 5 that we learned. Am I missing anything? Yep. Oh, right. It inside here, pregnancy and the hormone systems too. Yes, been asking you about the hormone system. So not only for the hormones during the pregnancy, what happens to menstrual cycles. So you got to understand and memorize the hormonal cycles of the estrogen or HCG, all other like estrogen, and all other hormones that are evolving into menstrual cycle as well as the pregnancy as well too. Okay, so we talked about some hormones like oxytocin during the pregnancy, not in the menstrual cycles. So this is a brief summary of the module 5, but as you can see, in module 5 is really broad, and sometimes we go into the depth and details too. Module 6 is actually starting from the ideas of this inheritance, or the main things about inheritance, the genetic change is simply about this one. The key word for the genetic change is always be the diversity, genetic. So I put the here, genetic, the diversity. Is the key word to describe the whole module 6. This actually goes through the whole module 6 in here. So I give you a little a roadmap of the module 6, so you know what's going to be happen, what you're going to learn. First, think about what causes the genetic diversity in our population or in the whole ecosystems. Obviously, we learned a lot about mutations. Mutations are one of the key factors of the creating the diversity in the genetic population or in the genetic pools or gene pools. Another is there could be some natural way or the artificial way of the creating something some artificial a technology. So, but generally in technologies. These are called the, not the natural way, natural goes to mutations too. Artificial technology in terms of that, you can think about how to create the different kind of genetic styles. I'm talking about a pollination is one type of that too. You may just think about all other cloning, genetic technologies we're using nowadays too. These will be included, but to understand the genetic technology, these are essential. These as in you really need to understand first, what if we have some diversity in our gene pool, what causes that? What kind of a consequence causes that? 2, if we change that, have a thinking for using the protein synthesis guys here. If we can alter a few bases of your DNA, what happens to the whole protein synthesis? Yep, you got to think of consequences of that. If we alter a little bit of that, we can, due to the transcription translation process, we can have a completely different proteins we produce too. So, in module 6, we're going to use a lot of the module 5 back on the content and background too. So, I assume that you know these contents. I really need to assume that. Otherwise, if you don't really get want some of the genetic technologies, I really strongly recommend you to revise the module 5, especially this part and the Mendel's law, inheritance parts too. Okay, as these two are almost this is, I would say, a module 5.5 rather than module 6. Okay, so today we're going to talk about the mutation first of all. Okay, you probably have some background about mutations. Mutation. Hayden, what is mutation? Change in? Change in. There are some alteration or change in the DNA. But when we say the DNA, are we saying like okay, let's use like, this is like a year 10 answer too. Shall we use like some using the understanding of the DNA structures? If we say change in DNA, there could be a various places it can take a place of change. What I mean is, inside DNA, could be a nitrogen bases, they change in base. Okay, then possibly change in like some proteins in the DNAs. Okay, they possibly change in the whole section of the DNA. That's known as gene. Okay, or there could be change in the chromosome as well too. So when we're saying the mutation, it means change in like your genetic materials. I would say genetic rather than DNA, rather changing in your genetic material. So it could be like the nitrogen base in DNA, the single or some multiple bases, or the protein, the histone, which is making the backbone of the DNAs. Whole section of DNA can be altered to or deleted. When I said change, it doesn't mean we are replacing to something. It means it could be deleted, could be added, anything that's considered to be a change. Chromosomal change means that whole chromosome, we can have a deletion, translocation, whatever that is. Now, within the mutation, we can categorize mutation into two categories again too. There could be a natural, okay, or I would say possibly, or rather naturals, non-spontaneous, the mutations, which means it's not inherited, it's a one-off, not inherited to the next generation, the next offspring. And it's not also be not like continuous. So what happened is basically you had one mutation in skin cell, and that's it. It's not going to be spread apart like just it stays there. Probably like just gonna deleted by your immune systems too. There could be a spontaneous of that too. Oh, for the non-spontaneous, it generally happens in your body cells, somatic cells in general. So what happens is you get some change in your somatic cell. It's not going to be passed on to the next generation. But if you have some change in your gametes, your sperms, or it could be your ovum or the egg, it will be the spontaneous, and this is going to be like passed on to the next generation. Okay, and this is due to something happens in your gamete. And it's got to pass on to the next generation over again. So because it's a permanent fix, permanent change of the gamete means that your next generation from your cell, it's got to be passed on to the whole a lot. Okay, we can also differentiate the mutation by looking at the what causes the mutations. In general, there are many factors, but in general, the agents causing the mutation is known as the mutagen. Mutagens, or also known as mutagenic agents. So let's before we actually proceed working out in here, let's have a think about what causes the mutation. You probably haven't heard it from your doctors, from your parents, somewhere too. Okay, Leona, what causes the mutation? Probably the easiest way is think about the cancer. What causes the cancer? What causes skin cancer, for example? Well, that's too fancy. What causes skin cancer? Why do we need to wear the slip slap, like all the wears, all the sunscreen? Why do we need to do that? What for? It's because of UV light, isn't it? I know it's the environmental factors. I'm just giving you like very specific example of that. What causes those cancer? Now, cancer is one of the probably the best example to understand the mutations too, which is the harmful mutations. Hayden, anything else? And what causes the cancer? Any type of cancer I'm talking about here. Exposure to
Radiation.
Oh, radiation. For example, if you ever heard about, like, you know, it's a full of rumor. If you're standing in front of the microwave, it can cause the cancer. So you probably have heard. It's a rumor, by the way, guys. Okay, it's not scientifically proven. But if you're shown by X-ray for longer period of time, you actually can get a cancer. Okay, and these are UV light, but they are the same type of that. Eric, anything else? Can anything cause a cancer? Cancer.
Cellular metabolism.
Whoa, okay. What about it?
I have no idea.
I have no idea. Okay. Have you guys heard about like the issues in I think it's early last year, some public schools in New South Wales kind of like prohibited because they have found that asbestos in the garden or the park load. Okay, those are the chemicals. And this is not only from the schoolyard too. Some of the old houses built in the 1950s, 1960s, they are built with the asbestos inside because they were famously used for the insulations. Now we know asbestos, which is a really fine little like a dust style. When you inhale that, it can cause a significant amount of the lung cancer. So those are the chemical factors too.
Isn't that just radiation?
Radiation?
Doesn't it, because the chemicals emit radiation?
Oh, that's a slightly different too. It's made the way we can differentiate the radiation to the chemical is directly you're inhaling or you touch to the chemicals. It means that the chemical itself, like some structure of the chemical, can cause the cancer or the mutations. Radiation is something that coming from emitting the light or the energy from the source. So you may say, if I have a uranium, I mean, we don't have a uranium in the real for two. You never consume, you never inject the uranium. So it doesn't really directly causing the cancer or the mutation because you don't really inject it. You don't really inhale it. But uranium is known to be a really famous radioactive decay or radioactive isotope. Means that it's emitting a lot of the radiations. So if you're standing next to a lot of the uranium, you're getting exposed to the radiation, not the uranium itself. Asbestos doesn't really emit the radiation. Rather, we inhale the asbestos into our respiratory system. It gets stuck into that. Just same as the smoking. Just same as smoking tobacco is also like drinking alcohols too. You're getting directly injected into your body, and they can cause some sort of the cancer or the mutations. Okay. Anything else can cause actually the cancer? You can imagine. You guys too young to get concerned about your health or the cancer, probably. Guys, if you hit like a 30 or 40 or 50, you probably got to know more about the cancers too. Have you guys heard about like your parents asking like prohibiting you to eating some burnt food, burnt meat? Have you heard that? You should eat it, that burnt meat. It can cause something. It's not good for you. Those burnt food. Why is that? I mean, it is proven. And have you guys heard about sausages, bacons, all that actually can cause the cancer? Oh, the fact, it is. They can cause the cancer. Why is that? Due to some sort of chemical or like, I would say the biological inside of that too, or chemical inside of that too, it can somehow altering the change or induce the change in your genetic materials, whether that be a DNA, chromosomes, or the genes too. So when I just divide the agents can cause the mutations in all the mutagens, I can categorize the few over here too. One, it's all well described in your workbook as well too. So page 2, let's highlight the second dot point here, please. Many mutations are carcinogenic, cancer-causing. This is because some mutations occur in genes that regulate the cell cycle and promote or suppress the cell divisions. We'll learn a little more about the cancer in the module 8, which is a non-infectious disease. But cancer, probably you have been aware of the cancers all the times too. Cancer is the abnormal growth of your cells. So the cell is not really having the same functionality. For example, if you have a lung cancer, the lung cell is not really functioning. Think about the consequences that the lung cell is not really functioning then too. Even if you breathe in, they don't really go for the gas exchange, which is essential for your life, essential for your the survival. So these mutations can cause in the cell cycles and they may result in increase in cell division with no differentiation, resulting in masses of the cell known as tumors. That's the actual meaning of the tumors then. So we can divide the mutation into the different sources. So page 2, the diagram shows that the possible typical sources of mutations, we can have cellular metabolism. So that could be more like not the environmental factors, more like a natural factors. So in your cell division, sometimes we may get some mutations accidentally. UV light exposure is something that's very important because we are surrounded by the UV light when you go outside. And remember that this is why you have to wear the sunscreen, because UV light is one of the prime factors can cause the skin cancer. It actually does a lot. Okay? Ionizing radiation, so I'm talking about any of the radiation types too. So those uranium, not only uranium too. Sometimes we are surrounded by those radioactive isotopes as well too. Chemical exposures too, as I said, and replication error that can cause that. Now, what's the consequences of this? The consequences of that is it's causing the DNA damage. Therefore, if you remember what happens to your translation transcription process, every single time you have something change in your DNA or genetic materials, they will now producing the whole different proteins from it. Whether that be a damaged or not functioning proteins, or maybe a completely different proteins that's functioning differently too. So it gets the cell cycle checkpoint activation and DNA repair, base excision repair, nucleotide excision repair, mismatch repair, and double-strand break repair like this too. So let's go a little more deep into some different type of the mutagens now. So chemical mutagen is one type of the mutagens. The chemical mutagen we have example of ingested chemical including alcohol, tar in tobacco smoke, some medication and some chemical in foods, especially charred and the fatty foods, and food additives and preservatives. So as I said, the bacons can cause the cancer if you get too much of that. Okay, but smoking tobacco and drinking alcohol can actually cause the cancer. It's known to be cancer factors. 2. Environmental irritation and the poisons such as organic solvents, for example, benzene, cleaning product, asbestos, coal tars, pesticides, and some hair dyes too. So this is the reason why when you're dealing with those chemicals, if you go to Bunnings, you can't see the chemicals. It's actually given a mark that you have to wear a mask. You have to wear the proper PPE for you too. Otherwise, it's just causing the cancer. So that's the 2 good example of the chemical mutagens. Okay. So page 3 gives you some example of those 3, cosmetics, all that, infectious agents and radiations, and all that too. Next page, biological. Cancer can be a mutation can also be happen due to some biological factors. For example, viruses. HIV is a good example of that. Okay. HIV actually does something to your genetic materials, means that it will altering the your DNA structures. Therefore, if you haven't heard about the HIV symptoms too, HIV itself doesn't really kill you, but it suppresses your whole immune system down. So after you get a HIV, if you get a cold or flu, there's a high chance you die because there's no medication to use, there's no immune system to fight against those flu. There is actually a study about COVID-19. It's actually ongoing research now too. We're actually researching that whether COVID-19 is affecting any mutations or not too. Okay. Probably it does. We don't know, because the viruses is generally like inducing some mutation to your cellular levels too. Because if you understand how the viruses is working, Hayden, if you have to understand how the virus is working in Module 7, you probably can understand then how we can possibly have change in your genetic materials as well too. Viruses is injecting some genetic material into the cell, so altering the whole structure of your cell itself too, and they get ruptured. Which means every single time you get a flu due to the virus or like in the COVID-19, there's a chance of that your genetic materials can a little bit altered. You never know. You never know. But those are considered to be a biological or natural occurring mutagens. So we are having these example on the page for the viruses now. Excuse me, my neck's going a little weird. Okay, I just included some of the examples for your readings too. You can refer to those if you need to in depth studies. All right, third is a physical mutagens. Okay, you got to really understand the difference between the physical and the chemicals too. Chemical is something that you're indirectly ingesting in. Like I gave an example of the asbestos, alcohol, even the tobacco smoking too. Physical mutagen is including heat and ionizing radiations. Or like simply like any of the UV light radiations is considered to be a physical, not the chemical. So those are physically altering your genes structure as well too. So when I said the radiation, I don't want to use the physics term in here because it's got to be really complicated, but simply this is called the EM wave or the ionizing radiations too. Can you see that? This section, after the visible light, we're getting the ionizing radiation sections. So what do we have in the ionizing radiation sections? We can have the examples of the ultraviolet, X-rays, gamma rays. Gamma rays is actually the one using to the cancer treatment to killing of the cancer cells. So if we get exposed to the UV light, X-rays, or gamma rays for like whether it's a short or long period of time, you may can attain the cancer or the mutation of the cells. Okay, it's unknown. It's a very unknown effect because it can be random. What about? Can you see that in the microwave section here, we have your smartphones there. Yes, your smartphone using the radiation, using the Wi-Fi is an example too. Guys, does that mean if I'm using too much Wi-Fi, am I getting cancer? If I'm using too much like playing the smartphone or placing the smartphone next to my head when I go to sleep, you probably heard about that too. Or the males, boys, we probably heard about putting your smartphone to your pockets may kill the sperm cells. We probably heard about the rumors too. Would that be true? Would that be true? It'll be a little negligible, I would say, because microwave is considered to be a non-ionizing radiation. So simply the way you need to understand that is non-ionizing is it's not really powerful. It's not really like that powerful. Yes, they're irradiating some of the waves, the EM waves, but it's not powerful to kill your sperm cell, kill your brain cells, kill all your causing the cancer or causing the mutations. But it doesn't mean it's safe to place the smartphones next to you too. Okay? But there is a chance that they may radiate some of those, the UV light or the X-rays times too. So still, it's recommended to get avoid from that too. All right, so electromagnetic radiation, UV radiation, and the other forms of ionized radiation is basically what I talked about too. So how do they actually do that? UV light or those radiation is, you can imagine about they're like a really sharp scalpels or sharp knife or the scissors. So those UV light can penetrate through. If you remember a little bit chemistry, gamma ray especially, the high penetrating power. Or even the X-ray. They have a high penetrating power. So if you're thinking about yourself going taking X-ray photos, you're exposed to an X-ray for like a second or maybe even less than that too. That's enough to get your lung picture. Because X-ray can expose, it kind of part through your lungs. We see that what's happening in that too. So think about yourself, if you get exposed to that too much time, your X-ray is penetrating through you just like bullets are hitting you, or like micro nano bullets hitting you too. Those kind of bullet is not just hurting your cells, it's actually targeting the DNA. So whilst we're having the DNA replications, okay, and when the DNA replication happens means the backbones are open like this. If we get exposed by the gamma ray and X-rays, the gamma ray X-ray can directly get altering all that sections. This means what? This will can whole change the whole structure of the DNAs, and that will be causing the significant mutations. If that happens to your sex of the gametes, rather they go through meiosis too, if the X-ray gamma ray pass through those sex cells, yes, it will pass on to the next generation. So this is actually known fact, and statistically, there's actually the radiographers and something working in the high risk industry. The infertility is quite common in that populations, because we don't know. We don't know what causes that. Even though we say like put the safety device and all that too, there possibly chance of that they possibly get exposed to those X-rays or gamma rays, so that they can't really have the babies because there might be some change mutation happens in gametes too. And this is the reason why I don't recommend them females do like radiographers, especially X-rays. Okay. Any questions for this? For all the mutation types, pretty straightforward. Okay. Okay, let's answer the question then. The 1.1. I help you to do. There are three questions. Okay, could you answer question 1 and 2? I give you about 5 to 10 minutes to answer these and go through the answers. Revise those booklets. Okay, defining the mutation, there could various like way we can define that, but I just choose say like it's a permanent alteration in the DNA sequence of the gene or the chromosomes, and it will have due to the errors in DNA replication repairs, so it can cause the it can be spontaneous. Okay, due to the errors. Due to the errors, okay, in the DNA replications, or the repair. So it's simply a cell division processes too. Okay, mutagens are any agent that increases the frequency or likelihood of the mutations. We call them mutagens. Now, in terms of the mutagens, we can have three factors. It can be a physical, including the UV light, or like the radiations, ionizing. The radiations, UV light is part of that too, I'll just write it down as this. Okay, it could be a chemical. Chemical as in like, it could be like any of those alcohol can cause that, or even the asbestos. Or like you may say the preservatives. Too much of those. Lastly, it can be by biological. That's like a viruses or prions can causes that as well too. But in terms of the frequency, the amount of the mutation we get, physical and chemical is more frequent compared to the biologicals, because biological, it takes quite a lot of time to research about it too. We only know a few at this moment now. Okay, but it's kind of proven that physical, all those, it can cause cancer rate significantly. Two, then what is the difference between ionizing and non-ionizing radiations between two? Okay, so I just give you like little like chemistry behind that too, the meaning of the ionizing. Those actually studied biochemistry in year 10 I would say year 11. You probably know what the mean ions too. So ionizing radiation refers to this has enough the energy to remove the electrons from the atoms. Okay, so I would say there's the high amount, most likely the significant amount of the energy carried. Example, as I said, X-ray, gamma ray, or the UV light, I consider it to be that too. This simply means if we put the light and the radiation to it, the electrons can also overexcited, they escape from the atomic structures. That's enough for now. That's enough. I'm not going to touch that from now too. Non-ionizing means it's kind of opposite to has a lower the energy level, and the let does not end, so that does not like have the sufficient the energy to ionize ionized atoms. That's what I can tell. Example, microwaves. It's a good example of that too. Visible light. Or the light we are seeing now is not really like an ionizing. I think that's enough to the examples now. Radio waves, let's include that. Radio waves. That radio wave including your Wi-Fi, or the 4G or 5G, if you want to say that too. Okay, that's how we can differentiate between two here. Question 3. How do transposable element cause a mutation? Okay, transposable element is the type of the biological, excuse me, biological mutations too. So page 5, please. This gives you some ideas about what the transposable elements are and therefore how it can cause a cancer. So transposable element, also known as TE, a short DNA sequence that move around the genome, giving them the name jumping genes. Highlight this point, please. The short DNA and jumping gene sequence. These are extremely common in eukaryotic genomes and are thought to comprise over 45% of the human genomes. This can also cause errors in the replication and interfere in the functions of certain genes. And multiple copies of the same sequence can change chromosome crossover point. And cause the errors in the chromosomal duplications. Okay. Excuse me. T may also insert themselves into the middle of the functional genes and interrupting its functions. If these errors are not corrected, these can result in the mutation that are passed to the next generation. The original mutation for one, page 5, please. Okay. The original mutation from one form of the hemophilia was caused the insertion of TE into a gene necessary for the effective blood clotting. So hemophilia is one of the genetic diseases that actually was quite common in Mediterraneans, which means your blood is not clotting well enough. So what happens is if you get like a cut, you get like a blood coming out, like there's blood leakage, then it's not really clotting. That means that there's a high chance of that you're losing a lot of blood before you get cured too, causing the death or something causing severe damage. So when this error occurs during the meiosis, it was passed on to the subsequent generation, resulting in the heritable genetic conditions, and T have also been linked to a certain cancer. For example, line 1 has a strongly recommended too. So let's summarize that for question the 3. I'll write it down the answers here. Question 3 answers. We can use that the information provided here. But in summary, how the transposable element causes again mutations. 1, I would say it causes by insertional mutagenesis. Mutagenesis simply means it can cause the cancer. Okay, means that the TE is basically inserts itself, okay, into a gene, or its regulatory. Or it's a regulatory region within the region of the genome. And this may causing the interrupting the coding sequences. The coding sequence. And altering the gene regulations too. Second, for that is the TE can also be like causing the genomic rearrangement. So it's got to be like whole that. So by inducing that means that it can cause the deletion. You can hold deleting that, duplications. You can also cause the inversion and or the translocation. Okay, and this will disrupt the not only the structures, gene structure, but all the and function of that too. So again, T, if you ask what the T is, it says short DNA sequence that are more around the genomes too. It can actually naturally can cause the cancer. So sometimes, if you think about it, you're not exposed to any of those radiation or none of those mutagens. But sometimes we still naturally get a cancer. It may be because of the genetic factors like your inheritance factors. For if your ladies, if your mom had, if your grandmom had the like say breast cancer, you maybe have a chance to have the breast cancers too. But despite all that genetic factors, this could be one of the factors, one of the reasons why you can get a cancer without, even though you're not really exposing to any of those mutagens. Okay, it doesn't mean it's a scary thing. It's kind of natural things as well too. Not only the human thing, it's actually a plant as well as the animals. They all actually can have the cancers too, due to that some of the materials they're carrying inside of the genomes. Okay, so try to give you some ideas about what the mutagens are and some what causes the mutagens. What the mutagens are and the mutation related to the mutagens too. Any questions about mutations before I move on to the different new chapter? Okay. Okay. Let's move on. So now what we're going to think about is we're going to think about the different type of the mutations. So I will like the consequence, more like a consequence of mutations then. Remember that mutagens, it doesn't really matter like a type of mutagens this time here too. We just assume like it's causing the mutations. Now depends on that what the site of the mutations. Site of the mutation, we can categorize mutation into there's some silent, nonsense, missense, or the point mutations. So highlight the point mutation, please. Point mutation, please. It means that mutation mutation in one or more base pairs. Base pair. So we call that a point because we have a very specific certain point that can be altered. Depends on that. We can divide the point mutation into three. One is called a silent. The second is called a nonsense. And the third is called a missense mutations. Remember that silent, nonsense, and missense are part of the point mutation where we get the change, just one single change in your DNA sequences there. So let's have a think about what the silent mutations are. Okay, to understand the point mutation, you actually need to have a good understanding about transcription. Okay, transcription again means that in the ribosome, the mRNA comes along, tRNA brings the anticodon and the corresponding amino acids to it. So, silent mutation first. A silent mutation occurs when substitution results in a new codon that still codes for the same amino acid. Highlight that, please. Yes, we have some change, there is a change, but no change in amino acid. When I say change, there's a change in your base, but it doesn't really change that base of amino acid too. Good example of that is we have the TTC, as in like we have DNA levels. If you remember the transcriptions, mRNA will copy that as AAG. Now, tRNA comes along and they go matching to the mRNA, the amino acid. It's called the RYS, lysosome. It will come out of the amino acid. Something happened to your DNA, so maybe like some of the mutagens happened. So it changed the TTC into TTT. Okay, that's what I mean a point mutation. We only have a point of changing that changing the base pair. Then corresponding mRNA would be AAA. So it seems like it's a lot of change, but corresponding the amino acid along with the AAA is actually the same amino acid, the lysosomes. Okay, if you remember like some of the table of the amino acid in the anticodons, there are actually the amino acids sharing the having the multiple codons. So even though we have a change to AAG to AAA, we still get the same protein or same of the amino acids too. So this is why we call it silent mutation. Even though we have a mutation, it doesn't really appear as we have a mutation, so we call it silent. Does that make sense to all too? So it doesn't mean like you need to memorize all that, amino acid tables too. The amino acid table will be given. Don't worry about it too. But sometimes you may get a questions like, hey, we have a change of one base pair there. Okay, what would be the corresponding amino acid? Therefore, identify what type of the mutation is. That's a possible question you may get. Does it make sense? Not too hard, not too difficult to understand the silent mutation for now. Can I move on? Okay. Next one. What about missense? It's not nonsense. Missense. You may just get what the missense mutation is from the title. Missense. It's probably due to like a substitution or like so that too. So missense mutation still produce that. Okay, and highlight the first sentence, please. Substitution mutation that result in amino acid replacement are said to be a missense. Replacement is the key for that. Okay, so this missense mutation still produces the protein, whether this altered protein can function properly or not depends on the importance of the amino acid that are replaced to. So the way I can summarize the missense is a change in amino acid. After we have a mutation, we have a change in amino acid. Okay, good example is if you have the red blood cell, the sickle cell disease. Can you see that we have normal sequence of the CGAG? Okay, if that produces the protein, we get the complete structure of the hemoglobin in your red blood cells. Now, if there's something happened, then if we substitute, replacing the A into T, it's not producing the VGUG, and corresponding amino acid would be VAR, competitive glue, from the glue. Means we now get complete different structure of your protein, complete different amino acid due to the amino acid. This is called a sickle cell. This is called like the incomplete the red blood cell in you. The hemoglobin in the red blood cell means that this red blood cell or the hemoglobin is not compatible to carry enough oxygen to your body. So people with this kind of disease actually can always be experience a dizziness or the fatigue due to that not enough oxygen in the body. So that is a good example of the missense. Again, missense means that there is a mutation, point mutation, and it produced the amino acid that may not be functioning or maybe have different functions. So we have a change in the amino acid after that too. Does that make sense? Okay. Now, this could be like in a spontaneous consecutive or non-consecutive, depends on the site of the mutation you have. As I said, if you have some somatic cells only, it may not be a consecutive. Means that in the next day or two, it may be fixed by your immune systems. But if that happens to your gametes, it can be passed on to your offspring, the next generations too. The last one in the point mutation is known as nonsense mutation. So, nonsense mutation known as when a substitution mutation results in the creation of stop codon, it is classified as a nonsense mutation. So, it is important to actually memorize at least the stop codons, UAA, UAG, UGA. These three are the stop codons. So, we have now UAA, UAG, and UGA. Those stop codons. So what happened if we got this kind of nonsense or the point mutation, the substitution of that? Your sequence of the amino acid will be now stopped, as we are replacing the base pair to the stop codon. So instead of them producing the amino acid, they will actually cutting the sequence of the polypeptide. So the way I can summarize that is a stopping. Basically stopping the polypeptide or the stopping the sequences, or not producing any furthermore too. It is well described on your diagram below, nonsense mutations. So without the mutation we have a TTC. Now after nonsense mutation we have ATC. Now that's a DNA basically, guys. It happens to DNA levels, not to the mRNA or tRNA. So mutation happens in your substitution happens in your DNAs always too. Corresponding, think about mRNA would be UAG. Now UAG will bring the matching to the anticodon of the tRNA. This brings nothing. So it will actually stop. It's kind of ordering the tRNA to, hey, I don't need anymore. I don't need any more amino acid. So that it will get stopped. It means that your amino acid or your polypeptide is not really completed. Maybe half, I don't know, maybe a quarter, even shorter, maybe long, maybe not really completed too. Means that this will significantly affecting your functionality of the cells as well as the proteins as well too. So it will actually function as abnormal, most likely. Okay, so the way you can understand the point mutation is, I would say substitution of the DNA, the one of the base pair. And then, as I said, the example, some categories of the point mutation we have, silent, nonsense, missense. Now, don't just think these are all different too. They're in, silent, nonsense, missense are in a category of the point mutation. But depends on what point you have a mutations on, or mutations at. You may have the different functionality too. Again, silent means we have a mutation, a point mutation, but doesn't have any impact because we still produce the same amino acid type. Nonsense means we have a point mutation and we'll stop the polypeptide sequencing or the polypeptide synthesis. Missense means we have a change in the point mutation and then it produces whole different amino acid. There will be changing amino acids too. The method too, you can summarize all the three different types of the point mutations too. It's quite common to we get in the school exam times to time. But any question for the point mutation for now? Hope that give you some clear sense about these mutation type then. All good? Okay. All right. Let's take 5 minutes break. We're going to come back for the different type of the mutation today too. All right, we kind of finished about point mutations. Another type of the mutation can happen in DNA sequences. You can think of backbones of DNA. Is called the frame shift mutation. Highlight that, please. Frame shift mutation involves one or two nucleotides being either be added or removed from the nucleotide sequence, altering every codon in that sequence from that point onward. So let's think about what that means exactly here. So this is different to the point mutation, which is substituting the one base. Substituting means we don't really remove, we don't really add the extra. So there'll be no change in the whole frame. But if we have frame shift, say for example, as A, T, G, C, A, G, T, A, C like this, it's kind of base pairing in here. Okay? If we have any of the point mutation, I'm just replacing one into the different one. So A, T, C here like this too. So the corresponding like the base pair here we like comes like now the the G, T, C, A, T, and G here forms 2. We may have a little change in the one base pairing too, but it doesn't really affecting the whole sequences yet. Now, difference between this point mutation and frame shift is we are actually adding the extra 1 or 2, the extra. So what I mean is in here, we're putting extra A into it. Or maybe like a 2 of those two. Now, consequences of that is, as we have an A, we need to have a corresponding T comes along too. This is now having the completely different cordons we formed. Previously, before we having the A and T, the purple one, we have ATC, CAG, TAC in that order. But as we replace, adding extra A and T, it's now going into ATC is the same, but we now have ACA and then CGTA. You can imagine that the corresponding like in mRNA, therefore tRNA will be completely different. This is kind of more significant compared to point mutation because we are actually changing the whole frame of the strand that the mRNA is copying, therefore the tRNA and amino acid consequently. That's known as a frame shift mutations, and there are also 2 types of frame mutations too in the second dot point please. The nucleotide insertion adds on 1 or 2 nucleotides, so insertion is one, and nucleotide deletion is the second one too. So similar things happen when you're deleting 1 or 2 of those two. Its whole frame's got to be shifted. Remember, the point mutation doesn't really induce the frame shift mutations because we only substituting one. It still be the same sequences or the codons. Frame shift by deleting or adding, inserting that, we got to complete like different changes. It's shown there on page 16 at the bottom over here too. So as you can see, like we are adding the extra extra like in the one frame shift too. So you can see like ACG, AGG was the normal order of the sequence, the frames. Now what they have done is by adding the extra that we now have shifting to the ACGA, GGA and goes here. Now this will completely making the different amino acid sequences too. Okay, that's the main difference between point and the frame shift mutations for now. So remember that the key point to understand and memorizing that is point is a substitution. Frame shift is insertion and deletion of the nucleotide, the base pair. Okay. All right, so if we go to the bigger term, not only just talking about nucleotide, which is a small piece of the base pair with the sugar, phosphate, and the base pairs, we may have mutation a lot of the chromosomes too. So we kind of covered that in year 10 a bit previously too, but it's still sharing the same contents. When we say the chromosomal mutation, what happens to the whole chromosomes itself? Remember the difference between or the relation between chromosomes to the genes to the DNA? I've been saying that quite a lot of times too. DNA is, or nucleotide is the building block of those two. Gene is a section of DNA. Chromosome is the collection of the DNA which is wrapped around the histones too. So in terms of the size, chromosome is a bigger terms. It means if we haven't changed the chromosomes, it'll be more significant compared to any of the points of frame shift. Means that there could be deletion, duplication, inversion, insertion, translocation of the whole lot of the chromosomes. As you can imagine, deletion means we get deleting some section of the chromosomes. We can have the duplication, copy and paste, or wrong copy and paste of the chromosome section. Inversion means inverted like a section of the chromosomes. Insertion means extra chromosomes kind of added. Now translocation means we have them locating the different parts. Any of those can cause the severe like a significant the result of the changes. Okay, so a good example of that would be some other things like we can have genetic diseases kind of caused by that. But another type of mutation is also known as aneuploidy, also known as like extra copies of the entire chromosomes too. Looking that in here, we can find the extra chromosomes or the less chromosomes too. So can you see like what happens in this the sex chromosome here. Aaron, what happens to these X and Y chromosomes?
They get duplicated.
They're duplicated? Yeah? How many sex chromosomes do we need to have?
23.
20 sex chromosomes, like sex chromosome.
2.
Yeah, it's either be what? X or X or
X or Y.
X or Y. How many?
1.
Only one. Only one. Means that, oh, as soon as we see that kind of genome map, the chromosome map, we will say, oh, this is something missing. These are like some sexual disease, some genetic disease, also like due to the aneuploidy. So we may have a multiple different type of the aneuploidy due to the sex chromosomes too. There could be a chance of the triple X syndrome, means that we have three of the X genotypes, and gender would be female. The incidence rate is quite high, guys. Okay, it's 1 out of 1,000. So there will be basically no observable characteristic, although typically very tall too. So it may not be like that significant. We may not notice that, but significant tall as in like maybe like 190 or 22 meters. Turner syndrome is the one that we have missing X chromosome like this. Okay, that's a Turner syndrome. Now, female have the incidence rate of the 2,500. Short statured, low sit and ears, webbed neck, and typically infertile. Due to that, the lack of one X chromosomes there. Okay, now we can think about the pedigree chart, like there's the Punnett square why we could not be infertile. Klinefelter syndrome is XXY, extra sex chromosome. It shows the phenotype of the male, and this means typically sterile, like often or tall statues too. So it's just like XXX. It doesn't really show in the clear sense of that. But when we have 4 sex chromosomes, XXXY, it's a 1 out of the 50,000. It's tall stature, testicle dysfunction, and intellectual impairments at the 2. So you may see clearly see that, oh, there's something happens to his genetic levels. We can also have XXY, YY, XYY too. Now, don't need to memorize all that, by the way, too. Later on, when we're talking about genetic diseases in the Module 8, we will have a chance to talk about actually some examples of including the Turner syndrome, Down syndrome. That is all non-infectious diseases, part of the genetic diseases too. But there's one type of mutations that possibly can cause by some kind of mutagens that we may just think about in here. So next page, page 19, 1.2, please. Draw a sequence of the diagram using a color and showing the base pairing in part of the A double-stranded DNA molecules to represent the following types of point mutation with the genes. So let's draw the those point and frame shift and deletion mutation that does not lead to frame shift mutations. Okay. Let's think about like base substitution, also known as what? The point mutations, first of all. It means that you may draw a flow chart of the 2 strands of DNA. Sequence like here, the strands of that. So A, T, G, C, A, T, G. Goes like here, and you go like C. Let's make it mRNA matching to that then. And the matching mRNA would be A2 DT, so U C U A C G U T to the A, C G to C here like this. This is mRNA strand. Now going through the point mutations, you may show that 1, 2, 3, 4, 5, 6, 7. One of those get changed, only one, so I just choose T that can change to the A here like this. This is a base substitution then. Remainder would be G, C, A, T, G would be the same. Then as a consequences of that, the mRNA, 2, 3, 4, 5, 6, 7. mRNA sequence now get changed into same, U is the same, and the rest of the C, G, U, A, C is the same as well too, but we now have different base pairing to the A, which goes to another U here too. This is what we call as point mutation or substitution mutations, base substitutions. Okay, just a single change in that single substitution. You okay, Eric?
Number, yep.
Okay, frame shift mutation. That would be drawing the same here. Okay, I show the sequence A T 1 2 3 4 5 6 7. So A T G C A T G here like this. Okay, now we can have the mRNA showing the corresponding 1 2. You may use the same thing too. So now if they go through the some DNA to mRNA, first of all we used to have that. Corresponding was again UACG UAC was initial one. Going through the frame shift mutation then, remember the DNA is now like we're extra like a base nucleotide added. So what do we have? 4, 5, 6, 7. I have 8 instead of the 7. So what do we have then here is we may get some extra. So I put the ATG first of all. I put extra C in the middle. I say G as well too. And the remainder would be just simply that following to C, A, T, and G here like this. Okay, the corresponding mRNA, then it'll be following to U, A, C, skip that for now, G, U, A, C here like this. Now what we have this here is, it's going to be C, G, and C. So codons in the mRNA, this used to be a codon, codon 1, codon 2. Now, as we added an extra, like a 2, inserted 2, this is codon 1, still be the same, but we now have codon 2 and up to codon 3. Can you see like a lot of the frame is now shifted, or like a whole changed compared to the point mutations? We now have completely different codons produced due to the insertion. This is due to the insertion. Probably the same things happen to like deletions too, but I just used one diagram for this one. That's a frame shift. Okay, last one. We may have a deletion, but not causing the frame shift. How could this be possible, Hayden? How could this be possible? We have a deletion, but it does not really make the shift, the frame shift. So I do the same thing here. A T G C A T C A T G goes here like this too. Okay, so it's a DNA. Let's put the C and G here more too. How is it possible that we have a deletion means that one or two of those are kind of missing, but we still don't have the frame shift. How can this be possible? Anyone? Any idea? Any idea? Any idea? Understanding a little bit about what we learned about transcription translation process.
Is it like during like RNA processing?
Good. Yeah. So what's the RNA processing? We only taking the section that we needed for the codons and the codings. So those sections called the introns, the exons too. It means all of those DNA, having this strand means that all of those got to be coded. Maybe I would say like this section here, this is like something we would call the intron, which is not used for the coding. Do you remember what we talked about RNA processing, splicing, and making that too? If the mRNA first copying a lot of the DNA, it contains some of the information which is not really used for the protein synthesis. So if these sections are deleted, means that we still have ATG and TGCG So ATG and TGCG. As you deleted those sections that were not used for the coding, we may get the still same corresponding the tRNA comes along to. So I show you that, like I actually do the same here. So without the mutations, first of all, corresponding mRNA, 2, 3, 4, 5, 6, 7, 8, 9. Okay. mRNA would be, as I said, like UAC, and then we can do GUA, and then CG, last one C, here like this. Okay. So during the mRNA processing means that these two, mRNA processing or splicing, that's got to be removed anyways too. So this is a primary mRNA. Now for the mRNA that comes to in the ribosome or ribosomal mRNA, now have actually that UAC, AC, and A, C, G, and C by removing this one out. Now, this is not a mutation. This is generally what happens to our bodies all the times too, called again DNA splicing, RNA splicing that too. We're removing those introns which is not used for the codons. This basically how it comes in a package. Do you remember I described that as if you receive the Christmas present, there's a gift wrap inside of that. We have a styrofoams. Those are the things we don't really consider to be a gift. Okay, so you're removing that anyways too. So the way you can think about this deletion is that you're just given a gift without the packaging after we deleted all the unnecessary parts. So mutation happened. Then it will show that ATGC8122. Okay, it'll be like this. After deletion happened, we now get ATG is the same, and removing the CA section, you'll get the TGCG as well too after deletion. Or mutate deletion of the G and U. Okay, so what happened? As we the mutation deleted the section that which is not really coded already. Already means that it will make the mRNA just goes like here, straight goes to this process ribosomal mRNA. Okay, that means that there will be no frame shift of the mRNA. There's therefore no change in our the amino acid peptides or the polypeptides. Okay, does it give you some sense about these? Okay. All right, 3 type of the mutation done. Let's move on to the next type of the mutation then. It's got also related to the coding and non-coding of this. So I will introduce a little, talk about a little more about coding and non-coding DNA sections. On your page, next page, and exercise 1.3, copy this one down, please. I give you a little more details about coding and non-coding, and known as the promoter and exon. We actually did that. If you remember the DNA sections, so I described that as this. Whole section of DNA comes like this. We start with the 5' to the 3'. That depends on the number of the sugars that. DNA always started from called the promoter, and also known as Tata box. Or it's actually AAA of that too. Tata box simply means this is the starting point of the DNA replication, or even the, so what do you call the translations. Then within inside of that, we can have a small ATG, known as starting codon, start codon, or even we say that the triplet. So Tata box is where the enzymes get bounded, and then this is like a start codon is where we get to starting point too. So you may just say this is like on your mark and starting point of the running, and that's got to initiate that too. Now within inside of the this DNA, we have the shaded region, we have some empty region, shaded region, and empty and shaded like this. And we finish with another, bit of space. We finish with another TAA, and I would call that a stop codon, and with the third prime. Those shaded region here, these are called the exon. Exon, as you know, is the one part that actually used for the kind of codings, and those not shaded are known as intron. Intron is the one that too. Okay, so this is DNA, our DNA sequences. So when our mRNA copies this one down, you may see that mRNA will copy the whole informations that is used for the ATG section here. So ignore this section. We're just taking this section from here. Start codon would have produced the mRNA goes to the UAC in your mRNA first of all, and then finish it with TAA. That's going to be stop codon of AUU. We want that in here, or AAA will be there too. But with inside of that, all section will be copied, comes downward, like that too. So we have a section of the exons. Okay, the section of the exons and the section of the intron. So these are the section of the copy from the exons, and those are the sections of the intron will be given. So after going through the another procedure called the RNA processing, using some of the tools, the mRNA is now going to be shortened. So you call the primary, the ribosomal RNA now. Okay, and this only has the sections of this, the regions of the exons. Means that in RNA processing, the sections of intron are removed for that. We kind of did that in the process of the transcription, and whole process known as transcription process, and then it's going to move it on to the exported to the ribosome, and arriving the ribosome, starting the translations, producing the polypeptide after that too. Okay, why am I talking about these intron and exon again too? Remember that I'm still talking about mutation, not about transcription today. You got to think about what happens then. We have mutation in promise promoters, start codon, intron, or even the exon, even the stop codons too. You got to think about those different characteristics of the different mutations too. So exon, also known as the coding DNA. Next page, please, after you copy that. What if we have mutations for the coding DNA? So this is basically what we haven't talked about previously too. I'm talking about point mutation, substitution of that. Or it could be like deletion, insertion. It doesn't really matter too. So first point, please. In general, mutation in the coding genes usually affect the type of the sequence of the amino acid in the protein and the end product. So this means it can be the point mutation. It can also be the frame shift mutations too. As in, like, if we change that one amino acid, sorry, the nucleotide of this one exon, one base pair, that's a point mutation. Depends on the change. It could be a silent, missense, nonsense too. We don't know. Okay, depends on the change. But it will definitely get changed something too. So as you can see, incorrect amino acid due to that, replacing the replacement single nucleotide, we get a whole different like amino acid produced. It's common. It's really easy to think about this as we're going through a lot of details about it here. Okay, and these errors are sometimes getting repaired a lot or two. But what if we have mutation in the introns? Okay, which is also known as the non-coding DNA. So non-coding regions as in like intron sections of that too. Okay, you may just think like, okay, that section is anyways not going to be coded, so it doesn't really matter we have mutations or not. So, but there will be something actually happen. Okay, it's not okay. So first dot point please, mutation in the protein coding regions of the genes have commonly been associated with human genetic disease. And then, okay, and many of these parts are due to the non-coding sections too. So what happened is this, even though we have like an intron, that section, introns are not really, introns are non-coding. Non-coding section. Okay, but depends on the mutation we get. If we have things like insertion or even the deletion of the introns too, or it could be a substitution too. Assume that we have that intron too. So if we have extra nucleotide introns, sometimes whilst the RNA polymerase copying that information to, they can actually misinterpret the intron, so that it's instead of saying the intron, they may misinterpret that as exon due to some changes too. Similar things happen to if you ever learned the computer like the programming too. If you leave like an extra dot, even though it's not really used, sometimes it's gonna stuff it up the whole orders of the systems too. Similar things happen in substitution. Sometimes changing the some orders of the intron can alter the lead to the misprint or the misunderstanding or the misinterpretation of the DNA or the RNAs too. So this actually can cause some genetic diseases. It does actually do. It's going to be minor. It could be a minor, but we never know what kind of change we're talking about here. So it's kind of given like a commonly given too. Okay, next, second dot point please. DNA codes for the end product are other than DNA, such as rRNA and small nuclear RNAs. These both have the important function in gene expressions, as we said, small nucleus. So we also shows that if the segment of non-coding DNA were removed from an egg cell, it could not develop properly either too. So non-coding section doesn't have, it actually has the functions of the development. So somehow we're still investigating through like what will we have that too, but there's a reason why we need that too. Have you thinking this way, guys? Christmas gift it must be wrapped. It must be wrapped with the styrofoam. It must be boxed. Okay, if that is not wrapped, it's highly likely it could be damaged while it's delivering to like your cousins or delivering to you. Okay, so in the case of that, we have non-coding section of the introns. There could be a chance of that possible non-development means there could be a possible damage of the exon sections too, or possibly misread of the information as well too. That's how we can interpret about the absence of the introns. Okay, next up, point 2. Studies are also involving the genetic makers show that mutation in non-coding DNA have also been associated with the predisposition to specific disease in adults too. Which means it could be such an enhancer sequence and also be shown to be genetically predisposed people to non-infectious disease such as heart disease, diabetes, cancer, obesity, among other disorders too. Okay, so you may just, you can't really say how introns, we don't need introns all the time too. Introns actually helping for your metabolism as well as your some developments too. So we need them, and this is what happens when we get a mutation on the intron section, not only the exon sections. Okay, and advantages of that too. All right, so it's showing the intron mutation, showing the exon, the mutation, and splicing that too. It's all given in depth and details about it. Last one is, what if we have mutation in our promoters and terminators? Okay, try to think, use a common sense in here first of all. Liana, what if we have mutation in our promoter, Tata box? It doesn't start the whole mRNA transcription because Tata box is known as the RNA polymerase with sits first and starting the promoters too. Means that you don't have starting line. You're missing the starting line at all too. So you don't know where to start it from. You may not start at all, or you may start in the random boxes too. So having mutation in those Tata of the promoters, it's given here, is neither be a mutation in this region will most likely result in either over or under expression of the genes, leading to either excess shortage of the gene products. Because it may maybe we have a Tata inside of the exon, the introns too. Maybe they started from the middle. Maybe not like start from the one before the Tata box too, going all the way directions. If we don't have the stop codon or the terminators too, same things happen. The RNA polymerase would not know when to stop. So it keeps going until it sees that, meets that another Tata box or the TAA stop codon in the next sequence too. Means that you're going to the next stadium because you don't know where the finishing goal is. So that's going to be happen to our mutation process too, and less likely happen. And there are many genetic diseases that could be resulting in change of promoter and terminators, and rarely monogenic disease and single genes only, and that could be like killed as well too. Okay, so let's answer these questions. I give you like question 1, question 2, there are 3, 4 questions. Could you answer the question 1 and 2 by referring to what we learned about coding and non-coding DNAs, 1 and 2? And I'll go through the answer 1, 2, 3, 4 together then. Yes, you can. Okay, start up with question 1. Hey, what is the function of the coding DNA? It's like kind of described a lot. So, okay, the function is, the function of coding DNA is to encode what we know as proteins. So this has all the relevant information about protein synthesis. So then there are basically one using that. So okay, let's write it down. The proteins, the carry out the various functions. For example, it can be like enzyme activity. It could be also be like structure support. Then lastly, for the regulation. And the cellular, some of the cellular regulation, I should say regulation of cellular, the processes. Okay, that's a function of the coding, which is pretty straightforward. Now, it's less known about the non-coding DNA sections too. The function of non-coding DNA, it has first, it's working for the regulatory elements. As I described that as, it's kind of some sort of packaging in your Christmas gift. It's including that the promoters is a part of the actually part of the non-coding DNAs, enhancers, and they like basically silencers, like all like regulatory functions too. 2, it's for the structural. Structural functions. So it gives them maintain the high order structure of the chromosomes, gives them high order of the chromosomes. Okay, and then it's also giving us these stability in genomes too. So genomic stability. That's the last part of that. So it means, so you can imagine like missing these or the mutation on these section 2, we may have some of the dysfunction of those promoters or the structure function and genetic stabilities. Question 2. Outline the effect of the mutation that occur in coding DNA and explain how these are different from the effect of the mutation that occurs in non-coding sections 2. So summarize that point at that effect of the mutation in the coding, mutations in the coding DNA. First of all, there are a lot of those. It could be a point. It just could be a point mutation, or you may say the substitution mutations of that too. Remembering the point mutation, it could be a silent. It could be missense. It could be like a nonsense. All that will be included in the coding region mutations. Okay. Also, there could be some frame shift mutations. If we have mutation in the coding DNA and due to insertion and deletion of the nucleotide in the coding section, which is called the exon sections then. Okay, what about the effect of mutation in non-coding DNA? You may think about from the all the function of non-coding DNA sections too. So what is first is the regulatory mutation. Especially if we have a mutation in your promoters or like some of the introns too, can affect the alter the binding affinity. So maybe like for example affecting the binding affinity of the enzyme on the promoter. Could be one promoter. Second is that there could be a structural mutation. As the intron or the section that is not used for the coding is have a really important role in your structure of the DNAs. So mutation in the telomeres, especially mutations in telomeres or the centromere. If you remember the cell division, the function of telomere and centromeres, they're involving the cell division, plaguing that too. So it means that that will not leading to the the chromosomal disability. The whole chromosome will not be like disabled at all too. The lastly is splicing mutation. Could be part of that. Okay. So maybe like it's kind of disrupting the whole splicing process. Splicing as in like we're cutting down those in the intron sections too. If we have any mutation in the intron section, as I said, they may not know whether we have to cut it or like have to leave it. So that's a possible like some mutation. We can think about this mutation part. 3. Is the following statement true or false? Mutations to non-coding regions of DNA will not influence the organisms. Explain your answer. Well, I just described a bunch of what happens to the if you have a mutation on the non-coding or intron sections too. The answer is no, false, obviously too. Yes, may not be significant as much as like in a coding DNA, but I would say definitely they have some impact. Whether that'll be a regulatory mutations, structure mutation, splicing mutations too, and it can cause the some kind of significant genetic diseases. That's what too. So you may just sharing this answer for the question 3, and the answer is false, as I said. But if you wanted to say add that to question 3, key point 2 going against for this statement is the mutations in non-coding regions lead to 1, as I said, the gene regulation. The gene will not be regulating properly too. 2, kind of sharing the same thing as structure mutations too, but I would say the chromosomal stability. And 3 would be what? The RNA processing, splicing. The after effect of those would be quite significant too, just like the you can't really measure which is more like causing the significant impact, but no, it would be still be there. 4. Describe the process by which introns are removed from the pre-mRNA molecule during the transcription. Use your diagram to illustrate this process. We kind of did that so in the previously too, in terms of that showing the structure of the introns and all that. Splicing is okay. I would call this is more like a module 5 rather than module 6. But another thing, things that you have to remember is, as I emphasize, module 5 is the backbone of the module 6. If you don't really understand the module 5, including transcription, translations, RNA processing, you will probably having a hard time to understand the mutation, or having a hard time that why is that causing that change in our polypeptide synthesis. Okay, so very, very important to revise those whole module 5 on the, your biology sections too. So, and this is the reason why I gave a bunch of the module 5 biology past paper questions for your holiday homework. Finish them? Yes. Finish them. Finish them. Did you mark them? Mark them? Mark them? Okay. How'd you go? Like, do you have any questions about the homework from that module 5? What kind of straightforward? Oh, okay. I mean, I've been using same question in your topic test. You've probably seen a really similar question in the school exam as well too. Okay, it's a matter of how much you practice those questions a lot for biology. It's not just saying, oh, I know the content. You probably know it's way different too. You know that, but you can't really write it. That means you don't really know that. So make sure you practice those questions. If you haven't finished that, I give a week extension to finish the Hayden by next week. Okay, answers should be in your Google Classroom. Mark them. Homework for the next week is some of these practice questions you can do for related to chapter 1. Here you go. It's a relatively short chapter, so I have not much to talk about this mutation sections too, unless you have a question. But besides that, next week we're starting some biology, like some some technologies in biologies, also known as biotechnologies, and genetic technologies too. Could you actually read through a bit of like chapter 2 before we come into the next classroom next Friday? I mean, because it's really broad. It's got to be a massive amount of the information coming through. So it's got a flow of that. So if you can read it through some of the chapter 2, I hope that's a good reading for you too. But that's all. I will post up the answers for the chapter 1 homework that you have today. So you can actually, same thing, like you can mark them. We can check the answers if you have any questions about them too. But if you have any questions, feel free to ask me. Any issue? Anything? Okay, that's all. I'll give you all the mark. Hope it's not raining. It is raining. It's going to be raining. It is raining. Damn. Shit. Raining.